Hi, this is Christopher Watford with EMS12lead.com. I'd like to welcome you to the inaugural attempt at screen recording some EMS education, and the first one's going to be axis determination. So let's jump right into this. This one's going to be quick, but it's also to show you how simple axis determination is. Einthoven's triangle, right here, drawn in poor fashion, begins with our electrodes. We get the left arm, the right arm, and the left leg. Three traditional electrodes forming it. And this represents leads 1, 2, and leads 3. Each of these are different views. We can draw little arrows to show which way they're looking. 2, 3, and lead 1. If we wanted to, we could derive some sort of axial reference system, which we call the hexaxial reference system. Lead 1 is at 0 degrees. 3 is at 120 degrees, and 2 is at 60 degrees. About the origin, centered about the heart, if we were to imagine it in the center of a sphere. From these, we also have the augmented limb leads, which are derived electrically from combinations of our other limb leads. And we know that we have AVF, AVL, and AVR. And for the purpose of this video, we'll concern ourselves with AVF, which is at 90 degrees. So the confusing part of this one is it puts lead 3 at 120 degrees on this side, lead 2 at 60 degrees on this side, and AVF down here at 90 degrees. And this isn't terribly helpful. So let's go ahead and let's take a look at an EKG, or rather let's look at the axis wheel. So the easier way to view this is a giant circle. We'll divide this up into 4 quadrants, and you'll see why in a second. We have lead 1 facing this way, and this is at 0 degrees. Lead 2 facing this way, 60 degrees. AVF here at 90 degrees. Lead 3 here at 120 degrees. We could also draw AVL, which is perpendicular view to lead 2, and this one's at negative 30 degrees. Then perpendicular to 3, we have AVR at negative 150 degrees. Now, for the terms of this video, this isn't necessarily helpful, as we're looking for rapid axis determination. So let's simplify this wheel greatly. Divide it into 4 quadrants. 1, AVF. We know this is the heart points to 90 degrees, heart points to 0 degrees. Right? If we recall, this would be a normal axis from 0 to 90. This would be right axis deviation from 90 to positive 180. Up here we have left axis deviation from 0 to negative 90. And then from negative 90 to negative 180 is extreme right axis deviation, or no man's land. Now you'll notice on left axis deviation, I've not drawn it inside here, because actually we have 2 parts. And that's split by AVL. Right? If it is from 0 to negative 30, this is normal or physiologic left axis deviation. And the left axis deviation we worry about is here from negative 30 to negative 90. So we can go ahead and we can fix this on up so that we know our normal axis extends from negative 30 to negative 90. So let's look at some EKGs, see how quickly we can determine the axis. So right here, we have ourselves a resting EKG from a 27-year-old male. Looks pretty normal to us. We have P waves. They're rounded, they're upright, they're symmetric. We have QRSs, they're associated. Everything appears pretty well what we would expect. Let's bring up our wheel here. We can see that we have positive deflections in 1. So if we look at this wheel here, positive deflections are going to be on this half of the sphere. We can go and color this on in. We have positive deflections in 1. We also have a positive deflection in AVF. So we can go color in this half. Notice where the two come together is here, between 0 and 90 degrees. This would be a normal axis. We can confirm this by looking at other leads, such as 3. It's going towards 3. If we recall, 3 comes this way. Yep. The positive half of 3 is over here. So we have positive here. We're working out. We also have positive in 2. Yep. 2 is over in this region here. So that works out for us as well. We look at AVR. This is going away from AVR. If we localize our axis to this region here, it is quite obvious opposite of AVR. We can go and we can erase to make this more visible. We can see that clearly. Since it's not negative in AVF, which is this top half, and it is not positive in AVR, we should be over here in this quadrant, a normal axis. So if it's up in 1 and up in AVF, it's localized to here, a normal axis. Let's take a look at another EKG. In this one, we're up in 1, so we know we're either here or here. So we'll go ahead and we'll color. We've determined we're up in 1. Now let's look at AVF. We're down in AVF. So if AVF points this way, this is down in AVF. So we are up in 1 and down in AVF. They converge up here, which we said is left axis deviation, which is broken into physiologic and pathologic. And this is where we need to look at another lead. So we need to look at another lead in this instance, and the best lead to look at here is 2. If we recall, 2 comes this way, right? Lead 2. So that means that negative 30, right? We split lead 2 into 2 regions, positive and negative. Lead 2 is clearly negative, so we know that it must be on this side over here. So where's our convergence? Our convergence happens to be in this region here. So where all 3 of them come together, and this is pathologic left axis deviation. If it was positive in 2, it would be a physiologic left axis deviation. So let's go take a look at another EKG. In this one we see a broad complex, appears to be fast rate tachycardia. So we'd call this a wide complex tachycardia of unknown etiology at the moment. The point of this course is not necessarily rhythm interpretation. We can see we're going up in 2, up in 3, down in 1, down in AVF. So let's start drawing. We are down in 1. So positive is on this half, negative is on this half. So let us represent that. We are down in 1, and we are positive in AVF. Okay, so we're positive in AVF. We are positive in 2, so we know we're somewhere over here. And we're positive in 3, so we also know we're somewhere over in here. So we've now localized ourselves to this quadrant over here, or right axis deviation. Pretty simple strategy, isn't it? We find where we are in 1, where we are in AVF, and we draw ourselves in the quadrant. Let's take a look at another EKG. We can do this pretty quickly. So if we take a look at this EKG, we see we are down in 1, and we are up in AVF. So we know we've localized ourselves to this quadrant over here, and we have a right axis deviation. However, I'd ask you to consider the fact that our P waves are also negative in 1, and AVR, for whatever reason, appears to be positive. In normal activation of the heart, AVR should never be positive, and our P waves should never be negative in 1. If we take a look at this, it appears that there's global negativity in 1. We've got both negative P waves, negative QRS, and a negative T. I would posit that the cause of this right axis deviation is actually due to a limb lead misplacement. Let's look at another EKG. In this one, we have a broad complex tachycardia. It appears to be fairly rapid, somewhere between 150 and 300, probably around 200 and 230. It is down in 1. And up in AVF. It is also down in 2 and up in 3. I would posit that this one is localized to right axis deviation due to up in AVF and down in 1. See, this is a pretty simple method, and we can rapidly go through these EKGs. Let's try one last one. This EKG is down in 1 and down in AVF. In this instance, we've localized this without any further to the extreme right axis deviation, or ERAD, or no man's land. This is bad. We should never come across this. And there's a couple causes of this: pure ventricular activation or limb lead misplacement. If this was a normal looking rhythm, I would probably hunt to find whether or not I've placed a limb lead on incorrectly. Due to this being a wide tachycardic rate, we can be somewhat safe to assume that this is pure ventricular in origin. However, it never hurts to apply the 3 a.m. test and make sure you've placed all your leads on correctly. Remember, ERAD is not good. We do not want to see ERAD. This person is likely experiencing ventricular tachycardia, and we probably need to intervene quickly. The other test to know that we've gotten this correct is AVR is positive, which means AVR is positive in this region over here. And remember what we said, normal activation of the ventricles, AVR is never positive. So there you have it, rapid determination of the axis using just leads 1 in AVF and using other leads on the surface EKG to help us determine a closer look at the axis. If you have any questions, feel free to join us on EMS12lead.com. Submit comments, let us know if you like this way of doing it. And if you do, we'll attempt more videos like this in the future. My name is Christopher Watford. Have yourself a good day.